healthcare, okay, so on and so forth. Just name it, you know, credit card detection, fraud detection, yeah, and whatnot, you know, the recommendation engine, just to find out potential customers, everywhere. Just name it, and Mapreduce is used there these days. The traditional way. So even in traditional way, you can split the data, you can search for the data, whether it matches, and finally you can cat, and then you can group all the data, right? This is the traditional method, okay? So grep is nothing but search, okay? Split data is you're splitting very big data into small chunks of data. You're searching in that data. Let's say you want to search my name. You search in this data, you search in this data, and then if it matches, it has the solution here, output here, and finally you concatenate, and then you have all matches here, or then you just display it, right? That's in traditional way. In Mapreduce, the concept is very similar. You have very big data, you split the data, you have a map process which takes the data, the split data, and transforms it into key value pair, and then here the partitioning function, don't worry about partitioning function for now. Here the key value pair is done, and then on that key value pair you have this reducer which will take this data, aggregate it, and then you have final result. So there are two things that you have to understand here, okay? The first thing, in mapper, splits the data into key value pair. Mapper, every mapper would take each record. Let's say for example here, okay, let's say quickly one example, okay, for you guys. My name is Bulram. Let's say I have this data and I want to find out the count of this, right? So what happens is that my one, name 1 is 1, again name 1 is 1, name 1 is 1, and Bulram. This is the output of a mapper. This is a very basic, it's like a hello world program of a Mapreduce, okay? That's what I'm telling you, okay? So this is my input. This is my output. Okay, this is not output, sorry, mapper output. And then reducer, and then, okay, there is one more inside it. There is, it's called shuffle and sort, which will take my, and then how many times my has been repeated here? 1. It will return list, key and list. Name, how many times it has been repeated? 1, 1, 1. Is, comma. So guys, if you do not understand Mapreduce programming, this is the best opportunity for you to learn, okay? I'm explaining it in very simple terms here. And if you do not understand, please let me know. It's extremely easy concept, but many people do not understand this. And the reducer will take the data and aggregate it. My 1, name, how many times has it been repeated? 3 times. Is, how many times has it been repeated? 3 times. Balram, how many times has it been repeated? 1 time. Did you understand this, guys? If you have understood this, a smiley will also do. If you have understood this, you have understood the concept of Mapreduce. Okay, Srijit, Syed, Gaurav says yes. Okay, excellent. Syed says yes. Okay, great guys, great, excellent. Deepesh says yes. Okay, says Siva. So basically, now just understand, mapper would take the data and then partition it, right? It's more like, does shuffle and sort phase do any sorting? Yes, it does sorting. It does sorting. Srijit, it does sorting on your keys. So in this case, right, B comes first. So this is a rough execution. Okay, it will be something like this: B, Okay, I think I'll have to explain to you in some other way. Let me see if I have a slide here. Okay, I have a slide here. I'll explain that to you. Srijit, please give me a couple of minutes, because it would have been easier if I could show a diagram and explain it to you. Okay? Okay, great. But then you did understand the concept of this. Mapper is just partitioning the data. It is mostly, we call it parallelizing. Okay, it parallelizes the data. Shuffle and sorts, it groups the data, aggregates the data. I mean, it is not aggregate, sorry, it just groups the data. It takes similar keys. In this case, see, my name 1, is name 1. So is this not grouping name into one place? That means it's taking all the keys together and it has key and list of values. So this is called as key, comma, list of values. Okay, that's the task of shuffle and sort. And reducer will just take the keys, list of values, loop through this list of values and add it. That's it. You are done with Mapreduce. Now let me take a step forward. Now you see, so Mapreduce, okay, and initially, right, everything is a key value pair. Okay, in Mapreduce, everything is a key value pair. So for the first time, when you give this output as, okay, just a second, okay, for the first time when you give this output here, right, this one and this one. For the first time when you give an output, my name is Balram, right? This is, okay, sorry, input. For the first time when you give this input to a mapper, it has to take this as a key value pair. It just cannot take it as a string. So the way, even though you would not have given a key value, you would just have given a string, the mapper will take that as a, index and string. Or input would have started at some point, right? Let's say this is the address, right? Let's say it randomly assigns 0, okay? And then if you have one more line, 1 and blah blah blah, and then 2, something else. So basically this is a dummy key that is passing here. It has no use, no significance, but mapper expects the data to be in a key value format. Even if it is not there, there has to be some dummy value there. Okay, so that's what it's saying. Here, you go here, there's a key value which the mapper takes, and then the output of it is, it's here, it's not list as yet. Okay, this is the output of shuffle and sort, but because we are only showing map and reduce here, this is what we have shown. Okay, map is list of key and values. Okay, list of key and values. Okay, the way it has been explained here is that this is list of values, right? Name, 1, 1, 1. So that's what it's trying to show here. Okay, basically we call the output of your shuffle and sort as key and list of values. So this is the accurate depiction of it. This is for your understanding. Okay. And then in reduce, it takes the key and list of values and then aggregates, and then you have the key and value pair output. So just think of this and you're done. Just think of this. If you do not understand this, everything is key value pair. Mapper takes K1. So the way we do is K1 V1, and then output of this is, I'm building on top of that. Okay guys, if you do not understand, please stop me. K2 V2. Right? The input here is K2 V2. Output here is K3 V3. Here. And output okay. Something like this. So that's what it's trying to explain. Basically, these are notations and nothing much. Okay, don't go into the inside of it. If you have understood my example, that's about it. You understood it. Okay. Now here it goes. The overall Mapreduce paradigm. We have an input. beer, deer, river, car, river, and this is the data. Okay. First, this got split into 1, 2, 3. Let's say this is running in 3 different servers. Okay. And then the output, the input of the mapper is, before even splitting it, okay, before even converting into a key value pair, you have the data split. And this is a key value pair. Key, let's say, is the dummy key here 0. As soon as this goes to mapping, deer becomes 1, BS becomes 1, river becomes 1, and then so on and so forth. Right? Are you guys able to understand till mapping? We're going to explain shuffling here. Guys, are we good with mapping? Okay, excellent. Thank you, Siva. So after this mapping is done, right, what happens is that this data is in different servers. Now see here, the deer is here and deer is here as well. Now there has to be some kind of shuffling, right? How do I aggregate this data if my deer is here and deer is here, and then I do not have network shuffling and sorting between them? So what happens is that the data is taken from this place, and then in my shuffling step, I just bring it here, deer, deer, and then I just sort the values. In this case, I have everything as 1, so it's of no importance. Otherwise, I would have values of 1, 2, and 3 whenever there is combined. So there is when inside here, there is shuffle and sort which takes place. Okay, shuffling and sortings are terms which are used accordingly. Now, if you have to go a little inside it, now this happens in one server, right? This is in one server. Shuffling happens over the networks, and this is over in your next server. So this is your not server. I'm sorry. This is in your mapper. This is in your reducer, and this you can think happens over the network. But if you have to go a little, if you have to dig a little deeper, shuffling to a great extent happens here as well. That's the architecture of Hadoop. I mean, you will not even realize it as to how it happens, but it happens to here. There is partition here. So if there are, let's say for example, 4 reducers, this data will be divided into 4 partitions here itself. 4 partitions, 4 partitions, 4 partitions, and each key, this key here, key here, key here, will have a hashtag associated with it. So deer is not actually deer. It will have hashtag. Let's say for example, deer has a hashtag of 1001, something like that. Even here, the deer will have a hashtag of same value. So based on that hashtag, there will be shuffle and sort, and then the value will come here. It's only for representation. The data is seen like that. Internally, when the calculation happens, it's all on hashtag. Okay. So it happens here, and finally, after you have reduced, the data will be something like this. In each of this, beer 2, car 2, deer 2, river 2, and then you have your final result. So basically, right, you have learned Python, okay, you have learned packages, but how do you use Python in order to process huge data? Right, that's the question that you need to be asking. For, let's say for example, Python is memory intensive, right? I mean, let's say if you are trying to process 1 GB of data in a system, maybe your system might crash. Or let's say you have a powerful system, then just try processing 4 5 GB in Python. It will take forever, right? So how is it that you will integrate Python and Hadoop so as to create a result or a product? That's the most important question that you need to ask. Hadoop does distributed processing, and then on top of that, Python can be used to process that distributed data. See, I can use Python to do this mapping, right? I will allow the whole Mapreduce to split the data, but I can use my code, which is simple, easy to code Python, to write my mapper and reducer, or partitioner as well, right? Think of the integration part. Okay, now I am teaching Hadoop separately, and then Python has been taught, right? But how do you integrate that is a big question. So that's what I'm trying to put this across, that as to how do we integrate. Now, data replication, or this is also called rack awareness. Okay, now these are extreme advanced concept in Mapreduce, so I'm not sure as to how much you can make sense out of it, but I'll explain. Okay, so let's say I did talk about it, right? So in this case, right, let's say for example, if I have a replication of 3, deer, beer and river will be replicated 3 times, deer, beer and river in 3 different servers. That's called replication, okay? So that if this fails, this is in one server, right, or one node. Let's say this node fails, it will go and start this as primary node. It will replace this other node which is available here, and then remove this out of the loop. Okay, so that's called replication parameter. In rack awareness, what it does is, it will try to place, let's say this is my map task, right? It will try to place a map task. This is 1 rack, 2 rack, and 3 rack. Okay, so it will try to place the data, the replicated data in its nearest rack. And then let's say it has a replication factor of 2, right? 1 data A, it stores here, it stores in another rack, and it stores in 3rd rack. Let's say for example, now I have my rack. 1 rack is in Bangalore, 1 rack is in Mumbai, and 1 rack is in, let's say New York, right? And then I have a replication factor of 2. So first time, the first replication will be done in, and then I'm working out of Bangalore, let's say. The first replication, this is the first data, right? The first replication will happen in Mumbai, and the second replication will happen in New York. But let me add one more to it. Let's say I have replication factor of 2, and I have one more rack which is available in Hyderabad. So Hadoop is intelligent enough to understand that this is in same geographical location, and then it will assign one in Hyderabad, the first one in Hyderabad, second one in Mumbai, and it will not use the 3rd rack, right? So it will take the geographical closeness and then assign each data to each rack. You do not have to worry about it. It's already taken care. The algorithm inside Hadoop already takes care of it. It's just for your understanding, okay? Now, Mapreduce submission and flows. Input data is distributed across nodes. I mean, you have seen that the input data is split across nodes. That's map which takes place. And then if you have combiners, there is combiners, okay? Whatever reducer did, right? In this case, okay? If I were to have used combiner, now I said this is mapper, part of mapper, and there is network exchange of data, and this is reducer, okay? Mapper, network exchange of data, and reducer. Let's say for example, I have car repeated 1 million times in one mapper. Then would that be a good idea? Would that be a good idea for me to pass 1 million of this data over network? Won't it clog the network? It will, right? I mean, the less number of network traffic I have, the better it is. Isn't it? Let's say I have one node in Bangalore, one in Mumbai, one in Hyderabad, right? And then the data is split across all the 3 different nodes. I mean, it can do that, right? So while it is doing that, the less number of data that I have to transfer over internet or over network, the better it is. So in those cases, what I would do is, instead of this reducer working here on an aggregated data or over the network, what I would do is I would implement this reducer here as well. It's called a mini reducer, okay? Instead of car 11, see here I have car 111, right? So in this case, let's say in this case, right, is name. In this case, if I use a combiner here, very simple concept, very easy to understand, you just have to be with me for some time. So let's say my one name 1. This is node 1, okay? That's the output of my combiner. Node 2 is name, right? Guys, be with me, okay? Be with me for some more time. Now, in this case, node 3. How many times is repeated? 2 times. So, and how many times name is repeated? 1. Balram is repeated 1. So now this is the data that I would pass over network, okay, and give it to shuffle and sort. Now see, instead of me sending car 1 time, 2 time, and so on and so forth, I am just sending car as 1, car 2. Does this help me in performance? Yes, it obviously does, right? So that's the task of a combiner here. It's also called as mini reducer. And then it goes over network, shuffle and sort, and then